So the first thing in terms of analyzing data, so now you pre-specified everything. You've tried to do that as much as you possibly can. This is what I would personally do. There's lots of different steps, and I'm kind of giving you kind of a rough way of doing this, and it's not perfect in any sort of way. Yeah, I'm not perfect, and this is kind of what I would do. The first thing that I would do is do construct validation of some sort, right? So you look to see at, do the things that you've measured, all the items that you've measured, say you've got like 6 items in something, right? And measuring some sort of construct. Do those hold together? Are they different? So you're trying to look for, I'm blanking on the term. Somebody's probably going to write a comment below. But where you're looking at how different it is from other constructs. But really what you're trying to do is just kind of do that sort of basic stuff, right? Is construct validation, making sure that the stuff you're looking at is actually measuring something, right? So is your, are you getting clustering with those items that you're looking at, right? So are they holding together as expected? And, if you don't get the things that are holding together, right, as expected, then you have to do a little bit of thinking with that, right? And so this is where, again, it's really hard to get away from those confirmation biases and stuff like that. But this is where you can sort of specify this in the paper that, it didn't necessarily hold together. But then we were thinking about different moderators and controls, and we started including those moderators and controls in that. And again, it's really difficult to get around this, right? So you're thinking, and you just have to be clear on what you're doing in your writing, right? You can't just be like, we did this all up front and, we pre-specified all this kind of stuff. But no, you got to actually say that, you actually have to sort of say that, we did this construct validation. This is the results we got. Didn't necessarily look as we were expecting. And so we were thinking about the different moderators in controls and that. And you have to sort of do that succinctly, as much as you can, but you sort of have to allude to that, right? So maybe there's moderators that are going on, right? So you looked at your sample, right? So your theory is maybe based on teenagers or something like that, how teenagers think. And then you're like, okay, well, I think I'm going to try to apply this to adults. And you try to apply it to how something happens within companies, for example. Well, those are totally different contexts. And so you have to think about, okay, what kind of variables do I need to include or controls I need to include to make sure that that is, that we are getting the construct validation. Now, again, careful with that because that could be, you could be doing sort of looking into the data a little bit too much. But, it's something that you have to sort of think about, and you just have to be clear with that upfront in as much as you possibly can, and just be right up front with that. And because especially if you spent a lot of money and a lot of time collecting the data, right? So some samples really easy to do if you're doing Amazon MTurk, really easy to do. It's pretty inexpensive and it's not a big deal. And that's where you might want to pilot test some of the stuff beforehand. But, after that, if you do, it takes you months to collect this data. It would be kind of foolish to throw this data away just because you don't get something that is not holding up the way that you expected. You want to sort of understand and write the story in the paper that you're kind of going through and thinking about different moderators. So different conditions, that's all you're looking at, right? So what are the conditions under which this might or might not hold? Maybe it's males versus females, right? So males is going to hold a little bit more than females. And maybe that really matters, or different control variables. And then you can include those in your analysis later on, right? So careful, but that's one thing that you could do. And then the second thing, so you're doing your construct validation. Sorry for the moving, I was just looking at my screen. So the second thing that I would do, and I'd probably even do this even before construct validation or at the same time, is you just want to plot the data. You just want to look at it. As trained as an engineer, so my undergrad was in engineering, and then being trained by mentors and stuff that were engineers. Plotting the data is going to save you it's going to save you years of heartache and stuff like that, because a lot of regression sort of techniques and all these sort of fancy techniques that you're going to want to jump into, they don't work that well because no data is really perfect. You will be surprised in terms of the analysis once you start looking at it. You're like, crap, that data is not at all perfect at all. That's the real world, right? So non-perfect stuff means that is a real world. That's real-time stuff. That's the stuff that really matters. The model or the regression techniques and all these fancy statistical things that you would use, those are specifically modeled on perfect data, right? So they're thinking about perfect data, and then once they come up with scenarios, they're like, okay, what if we had this condition? Let's change the model in this sort of way. But here's the thing: you can have all of this perfect data, and you can have these sort of different sort of regression techniques that sort of veer from that, right? Like heteroscedasticity, right? But here's the thing: is that most data have a series of imperfect things that are happening with it, right? So to find the right regression technique that has 6 or 7 imperfect things, sort of that is controlling or accounting for 6 or 7 imperfect things, is not going to happen. We just don't have those tools that are available at this moment. That just requires far too much model specification and stuff like that on the regression side. So you have to look at this real data, understand what you're going to do, and then sort of have a understanding of, okay, what is the real data? How is it going to not hold up with the analysis that we have, right? So what I like to do is just do really simple things like histograms, and then plotting. The most important sort of technique that I've learned is like scatter plots, right? So looking at X, Y. So you'd have a variable X on the bottom and then Y on the horizontal, and you want to look at that. And just plot that data, the data points that you have. Look at line plots, for example. Just look at the data and see what it's telling you. If you don't see anything that's there, most analysis, they should actually be, they should be eyeballed, right? So if there's nothing that's happening there, you're probably not expecting anything, or you're not going to see anything. They should be pretty much eyeballed, that you can look at it and you're like, yep, there's something going on there, right? Like, that's how clear it should be. You can almost, and that's the way the statistics is actually supposed to be, right? So it is not the fact that it's going to be this hard sort of line thing. It's that you can eyeball this stuff before you do these sort of fancy statistical techniques. And then you can use those fancy statistical techniques to sort of model that data, right? And say, okay, well, this is what's going to happen. And then you get a real much better sense of the data. And I think having this sort of practical approach where you're actually looking at this stuff rather than looking at numbers, and you're going to be tempted to just run those numbers and say, these are the numbers. If you do that, you're probably going to run into a lot of different issues, because there's going to be weird outlying things that are happening there. Like just a bunch of stuff. It's just going to be really weird. And you're like, I don't know what to do. But if you saw the data, you would know what to do, right? It becomes more clear once you actually see the data, and you're like, okay, I know what to do at this moment. So then after that, once you plot the data and you look at it and you're like, okay, there's something maybe there. And with those plots, some of those you can actually put in your papers and your thesis, right? And that's actually really cool if you have that, because that's real data that that nobody else sees, right? And if you see that, then other people can sort of say, so that's the thing, like they could say, okay, well, that statistical technique actually makes sense with what you did, or maybe that one didn't work. Maybe you should use this, right? So doing that, it's going to save you a world of hurt, and it's going to give you a lot more justification for the things that you're doing. All right, so then you want to think about, if it's not sort of working in the way that you think about, you want to sort of think about, like, is it fitting the data of past studies, right? So how is it actually working, and sort of what is not sort of, why might it not work based on the past studies and what you're doing, right? So you should be able to think about it and sort of logically think about all this stuff. And everything should sort of make sense in terms of what you're doing, and why it's actually working and not working. And as you're going through this, you should be writing it down, however that might be, and trying to tell that story later on, right? So a paper or a thesis. So a thesis, you have a lot more leeway, and you can write everything down. And that's what you should be doing as much as you possibly can, right? Just writing it down, right? Just write. With a paper, you have to do that, like take a thesis and condense it into like 30 pages. So what you're doing with that is that you're telling a story after. The story is cutting through all of this analysis and making sure you're touching upon such that somebody else can take that data, take that analysis and actually replicate what you're doing, right? So you should be touching upon everything as much as you possibly can. And being succinct as as much as you can, and have justifications and things for everything. So once you have done all of that and you sort of thought about, is this kind of making sense given like past data? Then what you want to do is, really think, and this should be basically your last step in terms of analyzing your data, is you just kind of run the regression results, but you do it one at a time. And I've learned this. This was kind of like a secret that nobody really, it really is open about. But why you want to do that is because you start seeing like models sort of changing weirdly, right? So you run all of your controls and all that kind of stuff, control variables and all that stuff. You just run each variable at a time, and you just put one variable in the model every single time. So the statistical textbooks actually talk about kind of doing this kind of thing. But, once you start analyzing the data, you have all these controls and it becomes real messy. It's going to save you a lot. And then just have those plots in a table that you can look at. You don't have to show all of that data later on in your thesis or those different tables and stuff like that. But you can show just your controls. But what you're looking for is is the analysis kind of bumping around, and is there kind of goofy things that are happening with the coefficients, right? All of a sudden something just goes really big and goes haywire in terms of your standard errors or your coefficients or something like that. And you're like, okay, something's weird going on. Why is that? What is going on? And you have to sort of think about what is going on and make, the appropriate change. Sometimes you just, one thing that tends to happen is maybe you should have logged a variable and didn't log it, or a transformation of a variable and you didn't do that. Because you just didn't think that was going to happen, right? You thought it was going to happen a completely different way. That's okay. Transforming the data is okay, but you have to write that down in terms of this is what we did. And again, the further you go away from what you did sort of pre-specified, the more that you have to kind of write this kind of stuff down, make sure that you're really clear as much as you can. So in terms of that, and then once you start looking at this and you see whether the results hold, or they're supported, quote unquote supported, your hypotheses are supported, then you can, you can either do this, a big old thumbs up and stop there, or, what I would personally do is do a bunch of robustness checks and really look into it a little bit more and think about some of these robustness checks. Now, I wouldn't do these robustness checks until you've gotten to the point where you're really kind of thinking about the data, and you've gotten to the point where you're kind of exhausted everything else that you've done in terms of the analysis, and you've written up your results. Then you start thinking about the robustness checks and thinking about different ways of doing this. And the reason is that you're bounded in terms of the time and resources that you have, and you can spend forever doing robustness checks. I'm serious. You can spend like a very long time of doing different kinds of variable transformations, all sorts of different kinds of regression techniques, and you can add hundreds of pages in terms of that. But you're really just thinking about, what kind of tests in terms of robustness techniques, what kind of tests can I create and think about that are going to show that my results are as robust as I possibly can. And it depends on your technique, and I'm not going to sort of go into all those different techniques and stuff like that and what you're trying to do. And it depends largely on your research question as well. So then you want to look at different robustness checks and go and just make sure that it's fairly robust. So here's the thing too, when you do robustness checks, expect the results are probably going to be different, right? So every analysis that you do, expect that with different dependent variables, with different regression techniques, just expect the results are going to be different, and that is okay. What you want to do is see that it's roughly, that they're roughly holding together, and then you can talk about why they are different. So this is where I wanted to point out in terms of, why it is, or what do you do when you actually get to the point where nothing is being supported, and you're like, okay, I have all these hypotheses, and I thought it would be supported, and it's not. I can't get the results to quote unquote work. All of that kind of stuff. So this is where you have to think about, okay, what is it that's different than the past in terms of what I'm doing with the theory that I'm doing? And what is really going on behind the scenes? This is where a lot of thoughtfulness goes on. And having null results that are well done is actually a really good thing. So I've been reading, if you've watched a couple of my older videos, I've been reading the biography by Walter Isaacson of Einstein. And the reason why he sort of got his initial claim to fame is that a lot of people were looking for this thing called ether in the world or in the universe, right? And they thought that waves traveled in this sort of secret fluid called ether, and people were doing all sorts of tests, and they could not get those tests to work, right? They tried everything, and they were doing really clever sort of experimental techniques and things like that to try to capture whether this ether actually existed, and nobody found that it existed no matter what they did. And Einstein came along and said, well, this doesn't exist, or we don't need this because we have X, Y, and Z. We have, the special theory of relativity that sort of changes this. And, all of these other sort of things he came up and just started thinking about, like, okay, there probably is a reason why we're not finding anything, right? And so that's what you have to think about. And especially if it's well done. And in fact, you can create a really cool study. So let's say your results don't hold. And then you go about and you say, what if I did this study to sort of show that these results don't hold, period, right? So then I go and do that again. And so you do multiple studies that sort of show that these results, as expected in the literature, don't hold, or they never hold. And then you postulate or think of, like, okay, so none of these things hold. It doesn't make any sense. So what if this particular sort of hypothesis or the way that we thought about it in the past was not correct? Maybe I can suggest this new theory. Maybe you come up with the special theory of relativity, right? And then you become the next Einstein. And that's really what you're trying to think about is, okay, things don't hold. Why is that the case? And then you start digging into why that's the case. And so the beauty with science and what the beauty with what you're doing, and this is where, you, in terms of the replication sort of thing that's going on, is that you should be writing down and just being clear in all the stuff that you've done as much as you can, right? And don't be sort of afraid to sort of explore different avenues, but be very systematic and explore those different avenues. If you put that in your paper and you put that in your dissertation or your thesis, that's super cool. And that is an amazing sort of rigorous study that you've done. Where the problem lies is when we choose not to disclose some things, right? So you go in an avenue and you just don't disclose it. And you're like, I didn't disclose that, and then I just miraculously found this sort of really interesting sort of supportive result. But what you should be doing is writing down and thinking through systematically all these different avenues that you chose. That's cool. And that is really good science too, right? If you've done all these different sort of techniques and stuff and nothing really held up, but then you found, okay, so you went in all these different ways, and then you found this one way that sort of held up, and you sort of talk about that, right? Like, what is that one way to hold up? In that one way, well, it might be, it might be spurious finding, but it might be a really cool, interesting insight that we've never thought about before. And then once you have that one way, then maybe you do a series of sort of other studies that you can confirm those results, right? So you have this sort of spurious kind of weird result, and you're like, well, this is weird. So spurious, or a weird result that could be spurious. You're like, this is weird. What if I did another sample and I reran the analysis again, and it was all rigorously done, and as much as you can, blinded and all that kind of stuff, right? And then you just rerun it and you see if those results will hold again. You're like, holy crap, they hold again. That's cool, right? Like maybe we found something that was interesting. And that's what you're trying to think about with this, is trying to be just transparent and trying to be open. And you could do that in your dissertation and go into these different routes. And that's what's really cool with this. And so with analyzing your thesis data or a survey or something like that, is really just think about it sort of systematic and just kind of working through these different sort of ways of doing that. And really use other people's feedback, really use your judgment in terms of disclosing all this stuff and just being transparent and being open and just being like, I did that. You don't have to hide anything. You shouldn't have to hide anything, and just be transparent. If you're hiding stuff, that's when it gets kind of suspicious, right? But if you're just open and, like me right now on YouTube, right? Like, this is me. I'm a giant nerd. I know that. I'm open about this, and other people might think that, this person has all these problems and all that kind of stuff. But no, you know what? I'm me, and I'm open, and this is who I am. And that's kind of the attitude that you need to take with analyzing your data. And especially if you find things that are not working, just being like, okay, that doesn't work. That's okay. Let's try to find someone else that works, and let's write this down. That didn't work. That sort of way didn't work, and let's just be transparent. So hopefully you like this video. Give me a thumbs up if you like it. Do subscribe to the YouTube channel. I do appreciate it. Take care and have a wonderful day. Bye.